And so now it's time to talk about a weak acid being titrated by a strong base. And the titration curve that we're going to learn about looks very similar to the one that you've already learned for a strong acid being titrated. There is one key difference in terms of the appearance, and even when the appearances are similar, the math that we use to plot those points is actually rather different because the theory is different when the acid is weak. But before we talk about the theory, let's quickly see some of these key points in an actual lab setting. Don't worry, I'll fast forward through the boring parts of the titration and just focus on the major ideas.
So I'm going to start this video by showing you our sample of interest. This is a salt known as KHP. In water it will dissociate into potassium ions that are unreactive and HP- ions which function like an acid. And so I've poured some out into this weighing paper, a tiny amount, and I'm going to now dissolve it in water. And now let me just stir it up some, get it to dissociate. And now I will add 4 drops of phenolphthalein indicator. Most, if not all of you, have used this before probably in some earlier titration lab. And what this will do is turn pink when we reach the equivalence point, for reasons that we'll go into later in the course.
Alright, here is our rather chaotic looking setup. So let's make sense of it. Here we have our KHP sample that we just saw dissolved in the water. Here is our burette full of strong base. It's sodium hydroxide, the classic strong base. And here is a pH probe, and we'll learn about how these things work when we get into electrochemistry. But for now, just know it measures the pH, and it's attached to this reader over here, which let's just switch our view. And so we see that our pH is acidic, which makes sense because HP- is a weak acid. So let's start this titration. To make it a bit more exciting, because you know these things can be a bit humdrum, let's do it in black and white. No, wait, we need to see a color change. Someone should really fire that director. Anywho, I'm going to start by adding 5 milliliters of NaOH, and then let's see what happens to the pH. So our pH has risen to 4.82, so it's increased by a little over 0.4. Now let's add some more titrants. Okay, so I've gotten us to this one region of the titration curve that's very different from what we observe when we do a strong acid, strong base titration. So let's quickly look at the pH. So the pH is now at 5.49. And let's see how much it changes when I add another 5 milliliters of strong base. And now look at the pH. It's only risen to 5.71. So the pH is changed by a smaller amount than before, even though the volume of base added was the same. And furthermore, without getting into logarithmic logic, the fact is that as pH values grow higher, the decreases in objective proton concentration become smaller. In other words, a change in pH from, say, 5 to 5.2 corresponds to 10 times less of a decrease in proton concentration than if we went from a pH of 4 to 4.2. So the decrease in proton concentration is actually significantly lower as a result of the 5 milliliters of base I just added as compared to the first 5 milliliters of base that I added. We'll get into what's happening here when we go through the theory, but just ask yourself, what type of solution resists changes in pH? You should think to yourself, a buffer solution, and this region, as we'll learn, is called the buffer region. Again, this does not happen when we titrate a strong acid with a strong base. Again, we'll try to understand that better when we get into the theory. But for now, let me get us to the equivalence point. Hopefully I don't overshoot this. Alright, take 2. I've made a new sample, and I've done most of the titration to get us up to that equivalence point. So let's quickly look at the pH and then see what happens. So there's our pH. It's climbed quite a bit. In fact, it's already over 7, and we haven't even hit the equivalence point yet. This is another critical difference between a strong acid versus a weak acid being titrated by a strong base. But let's see what happens when we add one more drop. There we go. If we look over here, we can see that the solution has actually turned color. It is hard to see with the camera, but hopefully you can tell that that is no longer clear. It is a faint pink. Now let's look at our pH. And let's fast forward because the pH needs some time to stabilize. Alright, so the pH has climbed quite a bit, and it's still climbing, all from that one drop. So this is analogous to what we saw in the strong acid, strong base titration, where we had that steep rise at the equivalence points. Now, if I kept going, this titration curve would eventually level off, as we saw before.